Hey, good morning, Algebra 1. This is Semester 2, Apex 5.4. So we've been talking about numerical data, numbers, quantitative data, numbers, and we've been talking about graphing them and some plots that we can make with them. So now we're going to talk about numerical data, and we're going to talk about tables specifically. So we already talked about a frequency table. A frequency table will state the category and the count for each category. So like if I said, I asked people if they had cats or dogs, okay, and I got, 3 people that had cats and 4 people that had dogs, okay? Or if I said, how many of you have a 5 in your address, or how many of you have a 6 in your address, right? So it's categories. So in this case, it doesn't necessarily, and you're going to see, it's not necessarily numbers, all numbers. This is going to be dealing with numbers and word categories. So then we have what's called a relative frequency table. So a relative frequency table will state the category and either the proportion, so like a fraction, the percentage, or both the proportion and the percentage. Okay, so, so if I have cats and dogs, so my proportion of cats would be 3 to 7, okay, because there's 3 people out of 7 total. My proportion of dogs would be 4 people out of 7. Okay, and then I would have to change those to fractions. So 3 divided by 7 would be about 0.42, okay, or 42%, 43%. And 4 divided by 7 would be about 57%. So, so that would be a relative frequency table. So we're talking about what is the frequency in relation to the whole or the entire amount. We have a couple of more tables here. So a two-way table is really useful when we're organizing data, categorized by 2 variables. So if we ask 20 children and adults whether they liked broccoli. So we're asking children and adults, okay? So that's one of the things we need to categorize. And the other would be whether they say yes or no. Okay, so in this case, it would be better to make a two-way table. And then we also have a joint relative frequency table that go with that. So the first thing I would need to do here is I need to add these up. So 3 plus 8 equals 11. And 7 plus 2 equals 9. So my total there is 20, which it should be because we said that we asked 20 people. So now we need to add these up and see if they also equal 20. So 3 plus 7 is 10, 8 plus 2 is 10, and when you add those up, they equal 20. Okay, so we need to know what our total is, and we need to make sure that the columns and rows add up to equal 20. So now we're going to change these values into proportions and percentages. So children that said yes, there were 3 out of 20 total, so that would be a 0.15. Children that said no would be 8 out of 20, which would be 0.4. Adults that said yes would be 7 out of 20, which equals 0.35. And adults that said no would be 2 out of 20, which equals 0.1. So now I'm going to add these up again, just like I did here. So 0.15 plus 0.4 is 0.55. 0.35 plus 0.1 is 0.45. And when I add those up, I should get 1 because I should get 100%. Okay, so same thing here, 0.15 plus 0.35 is 0.5. And 0.4 plus 0.1 is 0.5, which equals 1. Okay, so now we're talking about percent, so it needs to be 1 or 100%. Our marginal relative frequencies, I know there's a lot of terminology in here. Our marginal relative frequencies are found by adding the joint relative frequencies in each row and each column. Okay, so that's going to be the frequency over the total. So here we just added this to get 0.55, but really, and we could say 8 plus 3 is 11, so 11 out of 20, and that would give us 0.55 also. Okay, so that's our relative frequency. So the frequency that children answered is 0.55. All right, so let's take a look at this table. Okay, it's a two-way table still. It's got a category here and it's got a category here. Okay, so it says, so I think this has to do with students that have blue, green, or brown eyes in first period and second period. Okay, so to find the joint relative frequency of a first period student having brown eyes, we're going to divide 20 by 62. Okay, so we're looking at first period students with brown eyes. So there's 20 of those students. Our total is 62. And we will get about 0.32. So to find our joint relative frequency of a first period student having blue eyes, so we're looking for first period that has blue eyes. Okay, so we're going to divide 4 by our total number of students asked. Okay, so 4 divided by 62, which gives us about 0.06. And then our last one is to find the marginal relative frequency of having green eyes. Okay, so now this is only students that have green eyes. Okay, so we're going to use the total for green eyes divided by the total students, and that's going to give us about 0.23. Okay, so that wasn't just one block in the table, it was an entire row in the table. And we could do the same thing, you know, we could say, you know, what is the marginal relative frequency of being in second period? So if that's the case, we'd find our second period, add up all of our numbers and get 30, and we would do 30 divided by 62. So let's take a look at this. We're gonna create a table of joint marginal relative frequencies, okay, of the joint and marginal relative frequencies, which is the same exact thing we did up here. Okay, so why don't you guys try it? Pause the video, try it, and then jump back on and let's see if you have the same thing that I have. All right, hopefully you tried it. This is what I got. So my total was 210 when I added these up and added them together, and I checked it by doing it both ways. I added the rows up or the columns up and added them together. Okay, so for hardcover, it's 28 divided by 210. Nonfiction, 52 divided by 210. Okay. And then I have to double check and make sure when I add this and this, that it equals 1. And when I add this and this, it equals 1. Okay, so lots of good ways to check. All right, so let's go on ahead and move on to, I think the next page is still 5.4. Yes, so it's the last of 5.4, and then we will be done with chapter 5. So now we're going to talk about something called conditional relative frequency. So your conditional relative frequency is found by your joint relative frequency divided by your marginal relative frequency. Okay, so I'm going to walk you through this. Okay. So let's go on ahead and find our totals here. So freshmen, we need to add these all up, and we get 257. Sophomores, if we add them all up, we get 301. Juniors, 319, and seniors are 327. And now I'm going to add all of these to get my total of 1,204 students. So now I'm going to go on ahead and I'm going to add up my columns here. So blue-eyed girls. So the number of blue-eyed girls in the school is 195. The number of brown-eyed girls is 421. The number of blue-eyed boys is 173. And the number of brown-eyed girls is 415. And that really does make sense because you know, brown eyes genetically is usually the dominant gene, whereas blue-eyed is the recessive trait gene. So I'm married to, well, I'm married to my husband, obviously, and he has blonde hair, blue eyes, but both of our kids have brown hair and brown eyes because they take after me, because I have the dominant genes. So just, you know, just some interesting information there. So use the completed table to answer these questions. So it says there are blank blue-eyed sophomore boys. Okay, so we're going to look for blue-eyed boys that are sophomores, and there's 52 of them. There are blank students in the junior class. So juniors, we don't care what color eyes they have, 319. And there are blank girls with brown eyes. So now we're just looking for brown-eyed girls, and we don't care what grade they're in. So that's 421. Okay, so now we're going to look for the joint relative frequency of a blue-eyed senior girl. Okay, so blue-eyed senior. Okay, so blue-eyed girls that are senior is 63. And that's going to be divided by 1,204. So our joint relative frequency then is going to be 0.052. Okay, so there's, in other words, there's a 5% chance that if you're talking to a girl that's a senior in the school, she's going to have blue eyes. The other one is the marginal relative frequency of a freshman. So now we're just looking at the total number of freshmen, which is 257 over 1,204. So now that would be, what would that be? Oh, 257, that would be 0.213. Right, and that is it for 5.4. So we didn't actually use this formula today, but in a way we did, because really what we did is we did our blue-eyed out of our total and our senior out of our total. Okay, and then we had to divide them. Right. All right, have a great day, and I'll see you next time.